Okay, so remember, guys, I'm just gonna give you a little bit of a quick review or background to what I just said last lecture before I go into the business end of this chapter. So if you remember, okay, we are doing input space partitioning. So instead of considering the system under test itself and its structure and so on, I don't really care about this right now. What I really care about is the input domain, okay? The input domain. And it's all about modeling the input domain and seeing the different combinations that I can give to my software under test. And from my perspective, or one perspective, if the different input combinations that I'm given to the software under test are all equal, then are all working, then this is one way to validate that or verify that my software under test is actually working correctly. All right, let me erase this. So we said we can have uh, uh, our software domain, okay, modeled as such, okay, and that in this domain, we can describe a number of characteristics, okay? So again, I was using the football example. There is a difference between a characteristic and a difference between the actual values and variables that we have. So for a team, there's just the players that you're playing with. These are the actual variables, okay? But a team, given the same variables, can have more than one characteristic, okay? So characteristic number one, for example, could be the attack, whereas this may be way too thick. Whereas characteristic number two, I'm actually go like this. Characteristic number two is defense. And it's the same exact four players again that I'm going to have over here, that I'm going to have right over there. Okay, because the same system, same variables. Okay, but we're looking at these players, we're looking at these same variables from a completely different perspective. Okay, one is called attack and one is called defense. And accordingly, we decide on something called a partition scheme. So the meaning of a partition scheme is meaning it's one way that I can break down the input space for a particular characteristic into different blocks, okay? So partition scheme number one could have been something like this, okay? Partition scheme number two for the same characteristic one, which is attack, okay? So partition scheme, so this is one. Partition scheme two means I could have, for example, divided into something more like that. That's really up to me, okay? Now, these little squares, I call them blocks, like B1, B2, B3, B4, B1, B2, B3, B4, B5. Okay, now for a particular characteristic, I'm not gonna choose more than one scheme at the. I have to pick one at the end. Either I choose this one, all right, or I choose that one, but I can't choose both, okay? But for every different characteristic, I have to have a scheme decided. So a partition scheme for the defense, I could have decided it would be something as such. I wanted to break it down into three blocks, okay? Call it D1, D2, and D3. All right. Now, one thing I didn't actually mention in the last lecture is how do I go ahead and model and decide upon these blocks, okay? Obviously, we said those partition schemes need to satisfy two criteria. This I mentioned last lecture. Can somebody remind me what are the two criteria that any partition scheme has to satisfy? it has to be, the blocks has to be, let me see. Yeah, pairwise disjoint, we call it pairwise disjoint. And the other one, guys, oh, yeah, let me see what you're saying. Covers the entire domain, yes, complete. Okay, and again, guys, I need more than just Abdurrahman to be involved. Okay, I want everyone to be involved. Now, if you don't remember what pairwise disjoint, so let me just move here for a second, and complete means. So if I have an input domain as such, okay, this is the criterion that I have, B1, B2, and then B3. But this over here is empty. That doesn't satisfy the complete criteria. Okay. Another one, for example, had I had, for example, this is B1, B2. Or should I say, wait a second. B1, what is it? Yeah, B2 over here. I'm gonna use the red, and the red is going something like this. This is B3. Okay, that means that this area over here is both B1 and B2, so that doesn't satisfy the pairwise disjoint criteria, okay? So going back again over here at the top, I said to even come up with a scheme, all right, we have two different approaches to do this, okay? We have one way we decide we can call it the interface phase-based approach or functionality. Now, we'll begin with the interface, the functionality based. So interface, really all it considers from a very, very mechanical point of view is just the inputs. Okay, so I'm gonna take this, copy, and put it over there, paste, all right? So it just considers that and says, given these are my variables, and then what happens then is that the blocks that you decide upon tends to be more isolated, okay, in the sense that I'm gonna make every player, for example, a block on its own. Maybe not the best approach, because maybe like two players are playing defense and two players are playing attack. So it would have made more sense that would have attacked, okay? The other reason interface-based approach maybe not so practical is that it doesn't make sense of the different numbers or different values that something can be. For example, we said from 95 to 100, that's the A range. Now interface doesn't really understand that there's a range over here, so it ends up, instead of creating one block to represent 95 to 100, we end up creating multiple blocks. One is 95, one is 96, one is 97. And again, that defeats the purpose of creating blocks to begin with, okay? Now, it is nonetheless the safer approach, because remember when I was talking about the order of the files example in the last lecture, and we thought, oh, it's pretty easy to come up with a partition scheme, but then we found out that we can actually end up with not satisfying one of the two criteria, i.e. the pairwise disjoint and the complete criteria, and then we end up into troubles because of that, okay? So the interface-based approach, it's more conservative. It doesn't really understand the variables very much, doesn't make sense of them. All it cares about, all right, is creating as many blocks as possible. Now, the issue with practicality is that more characteristics equals, and more blocks equals more tests. So it's going to be a lot of work. It's going to be a lot of work. All right. Now, the functionality-based approach, what it does is it doesn't take into consideration the variables itself, but rather it takes into consideration the requirements. Okay, so the actual requirements from which I decided to create the system and its variable. And when I have the requirements in my hand, now I can look at these variables and make sense of them. Okay, now I can look at something like 95 to 100 and realize from the requirements that this is the A range. The code is not going to tell me that, only the requirements is going to tell me that. And I can say to myself, okay, so instead of creating 6 blocks, I'm going to create just 1 block and I'm going to call it the A block. Okay, and again, that's because I understand the requirements. Now, another thing, remember we said we can have multiple characteristics. So it's characteristic 1, characteristic 2. Characteristic 1 is called A, characteristic 2 is called B. Okay, A has 2 blocks, A1 and A2. B has 2 blocks, B1 and B2. And I remember at the end of the last lecture, we talked about the different criteria. So one of the things we said was the all combinations, correctly? Okay, which is basically when I'm creating a test case, I have to choose one value from C1 and one value from C2, and together, the value that I've chosen from C1 and C2 becomes my test case. Okay, so using the all combination criteria, I'm basically testing everything, A1 with B1, A1 with B2, sorry, A2 with B1, A2 with B2. Okay, good. That's all good. All right. This is what the interface-based approach tells us. Okay. Now, with the functionality-based approach, okay, it also gives us an understanding of the requirements and the domain, and it can alleviate some of the issues that results in creating excessive numbers of test cases, because as we saw in the last lecture, the more characteristics you add, the more blocks you add, and you start to do the all combinations, then the number of test cases, they blow up rather exponentially, okay? So maybe when I'm reading the requirements, I realize if I happen a case where I have A2 in the characteristic 1, it's never by definition going to be combined with B2. It just doesn't make sense, okay? So I can remove this one. Also, maybe reading the requirements, I realized that if I have the situation of A1, I realized it can never be combined with B1. So that's gone as well. Okay, and I'm left with just 2 tests instead of 4. So the functionality-based approach to break down, first of all, the and model the input space. Okay, it may lead to fewer characteristics and fewer blocks, leading to fewer tests. And then when I actually get to do the test, I can realize that I have some combinations that are infeasible, that they cannot actually be, that they don't actually work. They cannot be a feasible test. So I don't have to test it to begin with, because it's just never going to happen. All right. Any questions about this before I move on? Any questions about what I've covered? I need to see some text just to make sure that everybody's on track. Everybody following me? Okay. Okay, thank you, guys. Also, girls have Faye, Banan, Sadoun, and I'd like to hear your input as well too, huh? Wake up, guys, wake up. I know still 10:30, but I hope you're not following some other news. I know something, but you know, I need you to pay attention to the class. So anyway, everything is good so far. Type. I think somebody was saying something at the end. Okay, good. Type. let me now just remove this. Okay, and let's start all over here. So ultimately, we understood that we can have multiple characteristics. Okay, so this is characteristic number one. Okay, we said this is A1. Sorry, let's just call it A, B, C, and this is characteristic 2, 1, 2, 3. Characteristic number 3, we got E, F, G. Okay, and to create a test case, I have to choose, like I said, one value from each characteristic. Okay, and why are we doing that? Okay, now if we look at the football example again, okay, there's no such thing as a team that has an attack characteristic, which I'm going to choose from here, but it doesn't have a defense characteristic. Even if they're really horrible at defense, they still have a value at defense, and that characteristic exists nonetheless. So the input that I'm given, which is the team, it has two characteristics, and I have to provide the input for those two characteristics: how good they are in attack or bad, how good they are or bad they are in defense as well. Okay, so now basically I'm just going out and saying, okay, well, this is maybe test case number one, this is test case number two, this is test case number three. Okay, but you know, I want to be more thorough. I said, okay, well then I'll take the A1 and I'm going to move this way. I'm going to take the A1, I'm going to move that way. All right, but I want to be even more thorough because there's still some combinations that I haven't seen. So I'd like to say, well, I'm going to take A2 with the E, and then A2 with the F, A2 with the G. And what I'm actually obviously doing over here, I'm doing all the combinations, okay? Because if I do cover all the combinations, then I've basically covered every single situation that there is. And this is the most thorough type of testing that I can do from input space partitioning. And the number of test cases will be equal to the size of each of these characteristics multiplied with each other. Together, those make 27. Okay, but if I add one more test case, sorry, not characteristic, let's have to make it 4, 4, 5, 6, 7. Then I have to multiply this by 4, and suddenly this becomes what? Somebody calculate this for me. 24 plus multiplied by 7. 27 multiplied by 4, I mean. Somebody do the math for me quickly. 108. Yeah, there we go. I did it in my head. I beat you. All right. So anyway, 108 is pretty excessive, right? Okay. I mean, add one more characteristic that has 5 blocks, and then suddenly we're talking about 500 plus test cases. So obviously, it doesn't scale so much. If I have very few characteristics with very few blocks, then it's okay. I can scale it up. But as soon as I have too many characteristics and too many blocks, then the number of test cases is just blow up exponentially. So this is what I call the all combinations. Criteria. And I said this is actually the strongest. Okay. One way I can say, well, okay, let me just scale it down a little bit. Let me just make sure that each one of those blocks show up at least once. Okay. So I'll say, well, one test case, I'm going to go like this. I'm going to be very conservative and economic in my selection. So there's no point in choosing A again because I already chose it. No point in choosing 1 again because I already chose it. And E again because I already chose it. I go down this road and I go down this road and realize I have just 3 test cases. Okay. All right. Had I had another characteristic over here, okay, I would have basically just combined with them over there. So it would have been still 3 test cases. Okay. Only if that test case I had one more characteristic in it, 7, then 7 needs to show up. Now 7 needs to show up somewhere. Okay, 7 needs to show up somewhere. So what I'm gonna do is I'm gonna take it, I'm gonna end up, combining it with something I've already selected. And there's a bit of an overlap now. And I realize that the number of test cases that I have to create with each choice, it's called the each choice characteristic, is equal to the largest number of blocks in a characteristic. Okay, so characteristic, I got characteristic 1, 2, 3, and 4. Realize 4 is the biggest because it has 4 blocks. So I'm going to end up with 4 test cases. Okay, but again, had I done this with all combinations, that would have been 27 multiplied by 4. We said that's 108. So, okay, now 108 in comparison to 4, that's a bit extreme, right? So when I come over here and I say, this is my each choice criteria, I realize, well, okay, each choice is actually still the weakest. So we need to find some criteria that fit in the middle so we can hold the stick from the middle, okay? نمسك العصاية من النص, so to speak. Okay, so let me just delete this now. One way we can do this, okay, we have 2 approaches. Okay, the first of which is emphasizing, the first of which is about the structure of the blocks, and we're all talking just about combinations. Now, the other approach is about emphasis on the importance of particular blocks. Okay, so this is approach number 1, this is approach number 2. Okay, we'll begin first with approach number 1. Okay, so here we are, we got the situation A, B, C. This is characteristic 1. Then we have 1, 2, 3, characteristic 2. Okay, let me just move this because I'm gonna need some space. Characteristic 2. And then characteristic 3 is we said E, F, G. Okay, طيب. Set all combinations is 27, and the weakest is each choice gives me just 3. Now, one thing I can do is what I call a pairwise combinations criteria. Pairwise criteria. And pairwise criteria says that every 2 values need to at some point be combined in a test. Okay, this one and that one. See what I'm doing here? This one and that one. Okay, this one and this one, and so on and so forth. Okay, now if I set up the test requirements, what is it that I need to satisfy the coverage criteria for pairwise combinations criteria? Okay, basically, let's do it in a structured way. I have A1. Okay, so I'm going like this, and then I'm gonna go down this road. Okay, so you can follow me here. I'm doing A1, A2, A3. And then I'm gonna combine C1 with C2 as a pair. Okay, so then I have AE, AF, AG. Everybody following me on this so far? All right, guys, can you tell me if you're following? I'm not actually creating the actual test cases. I'm just saying the actual test requirements. Like if you guys are following me well, so tell me what are the remaining test requirements here, huh? Just shout them out. The second line here, second column. Speak louder, please. Or write, or anything. You can write if you want
For
to.
B.
I can actually see what you're writing. Yes. B1, got B2, B3, بعدين. And I need others answering as well. Abdurrahman is answering all the questions, guys. Yes, good, Saadun. Very good. Okay, so we got the G, and then from the C, we got the C1, 2, and 3, and then followed by the last CE, CF, CG. Okay, now what I have over here, again, I'm gonna say for the 100th time, this is not the test cases themselves. Okay, for me to create a test case, I have to have three things that I'm choosing. Okay, one from each characteristic. Okay, when I was doing the all combinations, or I was doing even each choice, I was actually choosing immediately from the blocks to create the actual test cases. All right, so the test requirements that I set up ended up being my test cases. This is not the case here. This is not the case here. My test requirements is to combine every two values. Now I have to create the test cases. So when I'm creating the test cases, I have to be a little smart because I am trying to, be conservative with my effort. Okay, so my first test case would be A1E. So that takes care of this one and that one. Next up would be, we already have the A and the 1 and the A and the E, so I can just go A to F. Somebody was saying something. There are missing requirements. Oh, yes. That's right. I'm not sure how I forgot that. So, yeah, we need to now combine the last two characteristics. Yeah, good eye, Abdurrahman. So we have, we begin with 1E, 1F, 1G, and then 2E, 2F, 2G, followed by 3E, 3F, and 3G. Okay, good job. Okay. So back again to here, we have A1. So this test case takes care of A1, AE, and 1E. Okay. A2F, because I already have the A and the 1, so I try to be conservative as much as possible. So I go A2, and I, maybe combine it with 2F, okay, because we haven't chosen the F. So here we are, we got this one taken care of, okay, and then 2F is right over there, it's taken care of. Next one up, guys, A3G, for example. I'm trying to be as conservative as possible. So I'm going down this line, was it, I've actually missed something again here. AF from, yeah, an AG. All right. So as you can see, when I'm doing this approach, I'm taking this column and then this column and then followed by a diagonal road this way. And as you'll see, probably next time is going to be something like this. And then the next time is going to be something like that or so. Okay, we'll see. Okay. So next time up, I'm going to take this column up over here. Okay, I have B1E. Okay, I could have created, actually, instead of 1E, let me choose, because we already have 1E over here. I could have just did B1F. Okay, so this way I get the 1F from over here. I'm trying to hit as many birds with the same stone. Okay, and then I got B2. Oops, let me go with black again. B2. What do you think, guys, we should do? B2, 2G, for example. Yeah, 2G over here. Sounds good. Okay, so B2, I'm taking care of this one. And then I got the BG done, and I got the 2G done over here. Last one, I could say B3. Well, I need to choose the you know, the B and the E. So that actually, I didn't actually use this one. That was A. So for the first one, I crossed out the wrong one, guys, by mistake. So the first one was this one, huh? Okay, and now the last one, which combines the B and the E, this is this one, followed by 3E. And you can tell immediately, like, what is the remaining ones, okay? So can somebody tell me, now that I've solved the first two columns, the first of which is gonna be C1, what should I combine it with? C1G, yes, excellent, Benan. You're getting into this. All right, second one. So let me just across one. So C1, and I get the CG. Okay, so these are the ones that are left. Okay, next one up, I can go C2, and with what else? C2E. Okay, good, good, good. C2, we said E. So we get the C2, we get the CE. What is the one that I'm, yeah, the 2E at the bottom over here. And finally, C3, and obviously F crosses out 1, 2, 3. How many test cases did I end up with? 9 test cases. Okay, if we looked at the extremes when we were doing this before, here the all combinations was, which is the strongest, 27. Somebody's trying to say something. Yeah, very good, Abdurrahman. The each choice was just 3. Pairwise, in the middle, which was 9. Okay, so you can see that the pairwise has resulted in me creating, you know, somewhere in the middle, not too strong with like 27 and not too weak with the each choice that is 3. But let me ask you a philosophical question, okay? So this is pairwise, meaning I'm combining 2 pairs, okay? Basically, kind of like, you know how we did node coverage, and then there was edge, and there was edge pair, and then 3 edge, and then 4 edge, and 5 edge, and 6 edge. And it's sort of like prime path coverage, which is the longest path that we have, is equal to the O combinations. That's really the concept here. So pairwise, I'm using 2 pairs, but I could have chosen 3 pairs. Okay. All right. Now I have 3 criterias over here. C1, C2, C3, and I want to combine, I want to create the test requirements for it. For 3 pair. You guys ready? Huh? Can you tell me, somebody smart enough, can you tell me how many test requirements are we going to end up with? Exactly. Okay. We're going to actually end up with 27. All right. Because really all I'm doing is the test requirements. Since I have to select 3 values from the 3 characteristics, which actually are all the characteristics that exist, which are the 3, I'm actually creating test requirements that are actually the same as the test cases you're going to end up with anyways. Okay, so if I have 3, and I'm saying for 3 pair coverage, and I actually have 3 criteria anyways, that's equal to all combinations. Okay, now had I had a 4th coverage over here, and I said listen 4, 5, 6, and I asked for 3 pair, no, things would have been completely different. Okay, again, because the test requirement that I'm creating, it's asking for 3 values. Okay, because I'm combining 3 things together at one point. Okay, so I'm doing something as such. Okay, whereas a test case is asking for 4 things, 1 from each criteria. Okay, and when I actually do the 3 pair coverage, when I have 4 criteria, four characteristics, should I say, I'm going to end up with more test cases at the end than pair coverage, and more than each choice, but less than all combinations. Okay, so had I had 4 criteria, 4 characteristics, okay, then my 3 pair would have been somewhere around over here. Okay, not sure how many exactly, I didn't do the math. All right, had we have, again, 3 characteristics, then the 3 pair would have been moved and have been equal to the all combinations. All right, is this clear, guys, for everyone? What I just covered, guys, I need some input. What I just covered, is it clear for everyone, guys? Everybody getting me? Did I miss you? Raya, thank you. Girls, and where is Fahd? Is Fahd here? No, Fahd is not here. Okay. All right. Right. How about we do some exercises here? Okay. This is characteristic 1, characteristic 2, characteristic 3. Okay. A, B, C, 1, 2, 3, E, and F. I want rapid answers, guys. Very, very quick answers. Yalla. All combinations. How many test cases? 18. How did you get the 18, Ibrahim? Show me the formula. So I'm going to ask you. So Ibrahim says 3 multiplied by 3 multiplied by 2, which is correct. This is what I want to see in the exam. Don't just write 18. Okay. I'll assume you just got it by complete accident. Okay. So all combination type, help. Each choice. How many test cases? 3. And why 3, Abanan? Why 3? Because yes, the largest. Don't just come on in an exam, don't just say the largest. I understand where you want to type the least in a lecture, but in an exam saying this is the largest characteristic has 3 blocks, and we got actually 2 of them. Okay, type. If I went 3 pair, how many test cases? 18. Type. How many test requirements? How many test requirements? Oh, 18 as well. Yes. Okay, good. Finally, 2 pair. That we don't actually have a formula for. All right. So we're gonna kind of have to do this manually. Can somebody tell me how many test cases we have? Sorry, how many test requirements? Let's begin with test requirements. Okay, we got 15. That's one answer. 15. So how guys, how did you get this answer 15? I'm seeing the same numbers showing up over and over again. Okay. Are you sure? I said test requirements. Okay. So we know we're going to combine C1 with C2. That gives me 9 test cases. And then I have C1 with C3. That gives me, so not test cases. I have to be very careful with what I'm saying. 9 test requirements. Then I got C1 with C3. That's 3 multiplied by 2. That's test. Okay. All right. What's the last one? Will be C2 multiplied by C3. Okay. And it's another 6. And this is what I want you to show me in the exam. So it's 21 test requirements. Now, doesn't mean I'm going to end up with 21 test cases. Very unlikely. Because as I'm creating the test cases, as we saw a few moments ago when we were doing the actual example, we started to cross out as many birds with the same stone when we're actually creating the test cases. Okay. So can somebody tell me how many test cases they're going to end up with in this particular situation? Now you have to work it out. By the way, I mean, you have to like pull out a pen and a paper and actually start working this out. I want you to work it out on your own first. Now, when you actually do this, don't begin immediately by creating the test cases. Okay, first step, I want you to tell me what are the actual test requirements by going A1, A2, A3, just like we did, followed by AE, AF. Okay, this is combining C1 with C2. This is combining C1 with C3. Okay, I want you to do this. Okay, I'm going to give you a few more minutes to solve that exercise. Okay, guys, how many test cases do you end up with? Okay. I'll give you some more time then. Anybody who comes up with an answer, just type it to me privately. Okay. I only received 2 answers so far, guys. Pick up the pace a little bit. You can't spend this much time solving this exercise in an exam. So, yalla. Faye, Ibrahim, Dreya, Sadoun. Yalla, go, go, go. Okay, so I think we'll stop here. I mean, not stop the class. I mean, stop the. I'm gonna give you like start working on it now. Before you start to do the exercise. Okay. First thing you want to do is you want to be able to calculate on the side how many test requirements that you have, so that when you actually create them, you can double check with what you have found out the test requirements equal. Now, another thing you want to do is you want to check, just figure out quickly the each choice and the all combinations. Okay, so we said the all combinations was 3 multiplied by 3, so it's 18. Okay, and each choice was just 3. So if you get a number above 18, then something is definitely went wrong. If you got a number that is below, then again, you've done something wrong. Then again, this is kind of like a self-hints for yourself, so that when you're actually solving the exercise, you feel like you're on the right track. But you come up with the test requirements, and the structured way. Divide C1, C2, and then C1 or C3 with the A column, or the first column. Now, next up, okay, so you got B, right? 1, 2, 3. Then with the last BE and BF. Somebody's trying to tell me something. Oh, is it still corrupted for guys? Somebody's saying that the audio is not coming in well. Okay, okay, good. So we're back again. I'm just writing down the actual test requirements. We got C1, 2, 3, then C again, E and F. Okay. And then we still have C2 multiplied by 7. I was going to do the same mistake again. So we have 1E and 1F, 2E and 2F, and finally 3E, 3F. Okay. And remember, we were saying how we had 6, 6, 9. Okay. So that is actually 6, 6, 9, which is going to be equal to 21. So we're good. Okay. We're actually good here. And why is this not erasing anymore? Type. Now we are in the business of creating the actual test cases. Test cases. Okay. Type. Can you tell me, guys, what do you have for test cases? How we should be doing this? Obviously, we want to do it in a structured approach, okay? Not ad hoc, random, all over the place. Okay. We're taking the first column over here. Copy. Paste. Okay, what is the first set of test cases? A1 with the E, A2 with the F. Now, unlike the last exercise, we don't have any more in C3, so we're gonna have to end up choosing something we already chose. So A1E takes care of this one, AE and 1E. A2F takes care of this one, AF, all right, and 2F. All right. Now we have to re-choose because 3E and 3F, sorry, AE and AF has already been chosen. So we're gonna choose 3. Might as well, we're gonna have to pick one. Masalan, we can choose the E one. Okay, we're gonna choose 3E here. All right. Good. Next up is this column over here. Yalla. So we got B1, 2, 3. Yalla, what's the last one? So B1, I can say, well, we have 1E, but we don't have 1F. Okay, so let's begin with the small one, F. Okay, so with the one we didn't choose, I don't mean the smaller one. So that takes care of B1 and BF and 1F. Now then we have B2. We haven't we haven't combined the B with the E just yet. So I'll take we'll take the E. Okay, so that takes care of B2, BF, and 2E. Finally, we need to use B3. The only thing now that is left at the bottom here is the 3F. Okay, so once we do it, we're good. Okay, so we're gonna go 3F over here to take care of this one. Okay, now all I have left is this part over here. Let's break them. Yeah, C1, C2, C3. All right, and so with the C1, C2, that takes care of all of these. I just need to take care of the combination of the C with the E and the C with the F. Okay, one time I'm gonna put an E, and one time I'm gonna put an F. Okay, that actually takes care of everything that I have. So boom, boom. Okay, and that takes care of the C and the F. And I still have the C3 over here. I have to do something with it. So I'm gonna end up picking anyone, F or E, doesn't matter. So I have over here. So we get 9 test cases. So those of you who sent me and said 9, that is absolutely correct. All right. And yeah, so that's actually going to be it for today. Remember, we said we have 2 approaches to creating the combinations. The first approach is based on the emphasis on the combinations and the number of blocks that exist in each characteristic. The second characteristic, sorry, the second approach to the coverage criteria is based on the emphasis and the importance that we're going to be putting on a particular block. Okay, Yani, just to give you a hint of what we're going to cover next lecture. Okay, so in this exercise, we were treating that A is equal to B in importance is equal to C. We never really differentiated that is any one of those that is even more important than the other one. Okay, well, what if A is something that is used 90% of the time, B was used 5% of the time, C was used 5% of the time. Okay, so what I'm going to do is I'm going to call A, I'm going to say this is the base choice. Okay, I'm going to call it saying because this is the one that I want to focus on the most. Okay, like I said, all combination is still the strongest, and we're just trying to find an approach to choose, like hold the stick in the middle. Okay, so we're not at the weakest, we're not at the strongest. Both edges are not good, both extremes are not good, and the pairwise we're still looking at the combinations between the different characteristics. But now this approach number 2, all right, is based on given a particular emphasis on a particular base. Now, how do we know which base is more than the next? This goes back to subject matter expertise, the requirements documentation, and basically like how the use cases are written, and what is the stakeholders are actually telling us. So maybe we'll realize that block A is happening a lot more than block B and C. So I'm going to end up creating some test cases, and those test cases have to pick a value from C1, C2, and C3. However, the test cases will tend to feature more of the blocks, that show more of the blocks that are in the yellow. Okay, what we call the base block. So this could have been a base block here, this could have been a base block there, and those would be the ones that would focus on the most. Okay, this will be the topic of our next lecture, and again we're going to be doing a whole bunch of exercises next lecture as well, and with it we're going to be ending up completing the input space partitioning chapter. Any questions, guys, about this before we end today's lecture? Any questions? Thank you, Abdurrahman. Okay, girls, Sadun, Reya, did you follow today's lecture well? Everything is fine? Okay. So I'm gonna be at the university today. So let me just pause the because there's no point. Just stop the recording.